So this rod is in vertical position. It's hanging, you can say this rod is hanging, and this is the axis of rotation. So you can say like this rod is hanging like this, and there is a this is string of the same length, and the mass m1 is attached here. So and the rod mass is m2. So when this m1 comes here, it reaches here, it hits this rod and sticks to it, and once it sticks to it, this whole system will acquire some angular velocity. Let it be omega 2 for the whole system that will contain this m1 as well as m2, and this will move to some angle theta. That's the maximum height that is going to that this rod will attain. So I want to find out this theta. So let's start it from here. When this mass m1 will reach here, it will acquire some angular velocity. Suppose that angular velocity attained by this while reaching here is omega 1. And this whole system, when it will hit this and stick to this rod, the whole system will acquire velocity omega 2. So first I am going to discuss this part. So when this rod, it reaches somewhere here, it's very nearby, when this m1, so it will acquire, this whole system will acquire some angular velocity. Let this will be omega 1. So the height, initial energy when it was here, then it was mg, this height is L, this height is L, so this is m1gl, and when it reaches here, it will acquire some angular velocity, that is omega 1, so half I omega 1 square. What will be the omega 1 for this mass? That will be half m1 L square omega 1. So the omega 1 will be uh, 2g over L. Omega 1 will be under root 2g over L. Now when it will collide, it will stick to this rod. So before collision, I will apply the law of conservation of angular momentum. So before collision, it was, angular momentum was I m1 omega 1, and after collision I m1 plus m2 omega 2. So I m1 was same m1 L square, m1 L square omega 1, and after that it was for rod it will be m2L square over 3 around this axis, around the center it's ml square by 12, and when we are going to calculate it, it will be ml square over 3. So and for m2, this is the distance which is there, so m1L square omega 2. So three m1 over m2 plus 3m1 omega 1 is equal to omega 2. That will be 3m1 over m2 plus 3m1 under root 2g over L is equal to omega 2. So this is the angular velocity that it will hold, the hold of the system will attain. suppose it reaches a height here. So my mass m1 is attached here, and the center of mass of this rod m2 will be at L by 2 distance, as the rod is uniform, L by 2 distance. And initially also it was L by this was the initial position. This was for m1 and this was for m2. This is the center of mass. So suppose the height attained by m1, if this is the line from where we are calculating, so initial this is the line from where we are calculating. Actually this is the center of mass for rod, as the rod is uniform. This is the mass m1, that is m2. This is the center of mass that was in at initial position, that was m2 and m1. So the initial, like this whole system will acquire angular velocity omega 2, which I calculated here. This whole system will acquire velocity angular velocity omega 2. So the initial energy will be half I rod plus m2, half I omega 2 square will be the velocity. And what will be the height, plus the center of mass for m2 is this is L by 2. So m2 g L by 2. This is the initial energy. Now what will be the final energy when this rod comes here? So this mass from here to here, the different distance is L. This is L cos theta. This is L cos theta, and this will be L. This will be L1 minus cos theta. So m1 m1g L1 minus cos theta plus the m2 will move from here to here. So what would be the new energy for m2? This is from this line I am calculating. So this will be m2g, and this will be L by 2 cos theta. This is L by 2 cos theta, and whole will be L minus L by 2 cos theta. L minus L by 2 cos theta. So for rod it was m2 L square over 3 plus for m2 m1 L square, and omega 2 square we can substitute it from here, and I am putting it here. So m1g L 1 minus cos theta plus m2g L by 2 1 minus cos theta. So by the help of, when we are going to substitute W2, that's omega 2 from here to here, we can calculate the angle theta. So this at this particular angle, this is the maximum height that can be attained by this rod after collision. Thank you.